Welcome to adding and subtracting radical expressions. So when you add radical expressions, you're going to use like terms in a sum or difference of radicals, and they have to have the same radicand and the same index. Radicand is the number that's going to be inside the radical. So for example, x is your radicand, and your index is the nth root of whatever you're taking. So that would be your index. So for example, if we are looking to simplify root 3 plus 2 root 7 plus 4 root 3, for our like terms is going to be root 3 because it shares the same index and it has the same radicand. We can't do anything with 2 root 7 because there's nothing, another term to go with it. So we leave that one alone. But when we add our two terms with root 3 together, we're going to add the number in front of root 3, the coefficient part. So there's an invisible 1 over here. Plus 4 would be 5 root 3, and then you leave the 2 root 7 alone. Let's try an example. So let's say we want to simplify 9 root 5 minus 5 root 5. Our like term is this root 5. And we're going to simplify the coefficients of that. So 9 minus 5 is 4 root 5. Let's try B. So right now I can't really do anything, but we can try to simplify this by writing our radicals in mixed radicals, and hopefully they share the same radicand at the very end. I'm going to rewrite 24 as 8 times 3 because 8 is a perfect cube, and then I can take the cube root of that. Then for 192, I want to rewrite this in perfect cubes. 64 is the perfect cube because that's 4 to the power of 3, and 64 times 3 will give us 192. For 375, because it ends in a 5, I probably want to think about 5 to the power of 3, and that's 125. 125 times 3 will give us 375. Okay, now I'm going to simplify this. So these are the ones I'm going to take out because they are perfect cubes. So the cube root of 8 is 2, and I'm left with the third root of 3. Taking out 64 will give us 4. We're left with cube root of 3. And lastly, the cube root of 125 is 5, and then we're left with cube root of 3. So our like term is the cube root of 3. And now I'm going to leave that cube root of 3 alone. What I'm going to do is subtract our coefficients. So that's 2 minus 4 minus 5. 2 minus 4 is negative 2. Negative 2 minus 5 is negative 7. So that would be our final answer. Moving on to C. Similar type of question as B in that we don't have the same radicand for us to go ahead and simplify this right away. So I'm going to have to try to write this into mixed radicals. For the root of 63, I'm going to rewrite 63, and I have to think about perfect squares as I do this. 63 can be written as 9 times 7. Remember that we can take the square root of 9 because that's 3. For the next one, I can change this to 4 times 10. I can take the square root of 4. And then we also can do 9 times 10 because we can take the square root of 9. And then lastly, I can do 4 times 7 here because I can take the square root of 4. So these are the ones that we can take out of the square root because we can square root them. They're perfect squares. The square root of 9 is 3. Then we're left with root 7. Square root of 4 is 2, and then we're left with root 10. Square root of 9 is 3. We're left with root 10. And lastly, we have 2 root 7. So the ones that I can collect my like terms with is 3 and negative 2 root 7. So that's just going to be root 7 because that's 3 minus 2 for the front. And then lastly, we have 2 root 10 minus 3 root 10. That's going to be negative 1 or negative root 10. Moving on to example 2, identify the values of the variables for which radical is defined and then simplify it. So right away, we know that a has to be larger than 0 or equal to it because we can't have negative numbers inside of a radical. And now we can go ahead and simplify. So we have the same radicand, which is a, and we have the same index, which is 2, the square root part. So then we have 6 plus 5 minus 11. 6 plus 5 is 11. Then we have minus 11 root a still, and you can clearly tell that that's 0. Moving on to b, we have root 50a squared b minus root a 8a squared b. So for a, this can be in the element of the reals. It can be a negative number or 0, really doesn't matter, just because we're going to square that number anyway, and if it's a negative number, it will become positive again. But b will be greater or equal to 0, because if it's a negative number, then we're going to have a negative in our root, so we don't want that. Now I'm going to go ahead and simplify. We look like we have almost the same thing, a squared b, but then the number on the inside is not the same, so we can't simplify this just yet. I'm going to break this down and write this into a mixed radical then. So I'm going to break down 50 as 25 times 2, because we can take the square root of 25. And then for 8, I'll do 4 times 2, because we can take the square root of 4, and 4 times 2 is 8. So I'm going to take out the 25 and the 4 because I can take the square root of them no problem. This is 5 root 2a squared b minus 2a squared b. Then we have like terms over here. The root of 2a squared b's are like terms, so we're just going to do 5 minus 2, and that is 3. Then for part C, similar to the last ones, looks pretty close. We have p to the power 3q. So I'm going to try to make this into a mixed radical for our first term. We can take the cube root of 27 because that's 3. And I'll leave the other term alone. Okay, and then we can just add the 3 and the 8 because our like term is the cube root of p to the power 3q. And that would be 11. But if you notice what we have on the inside here, we have p to the power 3. And if we take the cube root of that, we can actually simplify this more. Because the cube root of p cubed is just p. And then we're just left with the cube root of q. So again, from here, the cube root of p cubed, these things cancel out, and we're just left with p. The last thing I'm going to do is state where our radicals are defined. And because the cube root, p and q can be positive, negative, doesn't matter what, so it's an element of the reals. Our last example, we're just going to simplify. So we have 7 root m plus 2 root n plus 5 root n minus 3 root m. These two are like terms because they share root m, so 7 minus 3 is 4. And then we have 2 root n plus 5 root n, which is 7 root n. Moving on to b. So if we take a look at what we have here, we have 2 cube root of negative 3b plus 8 square root of negative 3b. So those two are not like terms, but this one and these ones are like terms, and then these two are like terms. So we're going to go ahead then and simplify this. For my underlined one with the cube root, we have 2 minus 9, which is negative 7, and then I leave my like term part alone. And then we have 8 plus 3, which is 11, and then we leave our like term alone, which is the square root of negative 3b. Our last one here. So all of our radicands are different right now, so we do need to simplify this and rewrite this all into simplified mixed radicals. I'm going to rewrite 32 as 16 times 2 because I can take the square root of 16. I'm also going to rewrite a to the power of 5 as a to the power of 4 times a to the power of 1. So that's the same thing as a to the power of 5. But I can take the square root of a to the power of 4. Moving on to the next term, I'm going to rewrite 45 as 9 times 5 because I can take the square root of 9. And I'm going to rewrite b cubed as b squared times b to the power of 1, which means the same thing. Again, it's because I can take the square root of b squared, no problem. For our next term, I'm going to rewrite 25 as 25 times 5, and we can just leave b alone. So for 25, I can take the square root of that later on. And then lastly, for our very last term here, I'm going to rewrite 72 as 36 times 2, a squared times a to the power of 1. So now we are going to go ahead and simplify this. So the square root of 16 is 4. And I can also take this a to the power of 4 out. So on the side here, this is what this looks like. And I can rewrite this as a squared times a squared as well, which is just going to be a times a if I were to take the square root of each. So then that means that we're left with just a squared if we take the square root of a to the power of 4. And then what's left inside, we have a 2a on the inside. For our next term, I'm going to take out the 9 because the square root of 9 is 3. And I can also take the square root of b squared, which is b. What we have left over is 5b on the inside of our radical. For our next term, I can take out the square root of 25, which is 5. And then leave whatever's on the inside, and that's 5b. For our last term, we can take out the square root of 36 and this a squared. Square root of 36 is 6, and then the square root of a squared is a, and then we're left with 2a on the inside. Now we're going to simplify whatever's outside of our radical. So whatever I'm underlining here, that's what we're simplifying. 3 times 4 is 12. Then we're left with a squared. Then we have 2 times 3 times b, which is 6b. 5b times 5 is 25b. And then a times 6 times a is 12a squared. So now we're going to simplify our like terms. These two are like terms, and they're just going to actually cancel out because 12a squared root of 2a minus 12a squared root 2a, that's just 0. Negative 6b root 5b plus 25b root 5b. So negative 6b plus 25b is 19b. We're left with root 5b, and that'll be